Okay. So last lecture, what we have discussed. Last lecture, what we have discussed.
Software, sir.
Yes, I have demonstrated you the how to execute VHDL codes using Xilinx ISC simulator, right? So I have demonstrated you two or three examples, right? And I hope you have clear with this. And if you have any doubt regarding that, so uh, I will share you one document in that the entire execution process from start to end, right? From to creating source to what we can say, observing the test bench waveform. The entire process I have mentioned in that document or notes, you can say. You can go through that, okay? And I have shared that in your that study material sheet, right? So in unit number 1, I have sorry, in unit number 2, I have studied the I have shared that file with you, so you can go through that and once again just go through that document, and still if you have any doubt you can ask me anytime, okay? So entire process of execution from the
Okay.
creating source to how to observe and how to test the test bench waveform. So everything, every step I have mentioned there, okay? You can go through that PDF file that I have shared in that study material sheet, and you can get the things done for you. Okay. Now today we will start with the unit number 3, that is Verilog modules for the combinational and sequential circuits. So in unit number 2, what we have studied, VHDL modules for the combinational and sequential logic. Okay. Now in this unit we supposed to go for the Verilog model. As I told you, HDL has two types. First one is a Verilog, second one is a VHDL. So VHDL part we have studied. Now it's time to go for a Verilog part. Now same procedure and again same things we will study for this Verilog also, right? As we have studied for the VHDL. What we have studied for VHDL, its structure, then data types, data objects, operands, right? Different sequential concurrent statement, how to use case statement, how to use if loop, how to use while loop, for loop, its syntax. So similarly, for Verilog also, see, this is another language. There are two languages. One is VHDL that we have studied. This another language, Verilog, it is C based, right? Basically, what is difference between VHDL and Verilog? Verilog is much similar to the C language, right? But VHDL has its own syntax. Verilog also has its own syntax, but that syntax is much similar with the C language. Its syntax is much similar with the C language. Now we will start with this. Okay. Now, as you know, hardware description language, right? So it has two most commonly used HDL, VHDL and Verilog. VHDL we have already studied. Now about this Verilog. This Verilog can be used to describe design at four levels of abstraction, right? In case of VHDL, how much level of abstraction we are getting there? Three levels of abstraction. But in case of Verilog, we are getting four levels of abstraction. And which are those? First one is the algorithmic level. That means whatever the Verilog code or VHDL code that we are writing, in case of VHDL, that is the VHDL code. In case of Verilog, that is the C code or Verilog code, you can say. So that is the algorithmic level. Second one is the register transfer level. That RTL schematic, right? I have shown you in the last session that RTL is stands for register transfer level. So that RTL schematic is the second level. And third level also that we have seen in the, it is switch level, right? When we are double clicking on that RTL box, we are getting the inside structure architecture that have many gates and many interconnections and flip flops and all that. So that internal model is gate level. So in VADL we have up to this, but in case of Verilog we can have one more level, that is switch level. Means this algorithmic register gate level. These three levels are there in VHDL. But with Verilog, we have one more register of abstraction, one more level of abstraction, that is switch level. That means again inside that individual gate, you are able to see different MOSFET structures, different MOS transistor structure inside the gate, right? So Verilog has four levels of abstraction. VHDL has three levels of abstraction. Okay, remember this thing. Now we will start with the what we can say some lexical tokens that we are using in the Verilog. That means what the white space means, what are different comments means. So that we are going to study with in this lexical token. Now this white spaces separates the words and contain spaces, tabs, new lines and form feeds. Okay, means in two different what we can say words, you have to maintain a space. So that is about white space. Then comment. What do you mean by comment? Comments can be specified in two ways, exactly as in a C or C++. That means तुम्ही कमेंट देता का नाही कुठल्याही स्टेटमेंटच्या पुढे की what that line of code will execute. So similar manner you can put the comment in what I can say Verilog language also, similar to the C. If you double backslash two lines, it will get commented. That means you can write any comment in front of that line. So that is about the comment. Then numbers. How you can write numbers in different binary, octal, decimal, hexadecimal in case of Verilog. So these are the few examples that you can see here. This is the example. If you want to write any 3-bit number, for example 001, it is 3-bit number. How you can write in case of Verilog? 3, comma B, that B for bit, and you have to mention the bit. That means 0, 1, 1. That means it's a 3-bit number, and which are those bits? 0, 0, 1. Okay. Now similarly in case of decimal, you can write 5, comma D, D for decimal, and you have to write the decimal number, that is 30. Similarly in case of hexadecimal number, that means it's a 5-bit decimal number, and which is that number? 30, right? Its meaning is 16 apostrophe H, that 16 means 16-bit hexadecimal number, and which is that number? 5ED4. So this is a 16-bit hexadecimal number. In this manner, you can write a number in Verilog. Now, there is identifiers. Now, what do you mean by identifiers? The identifiers are user-defined words for variables, function names, module names, block names, and instance names. Then these identifiers are the user-defined words. So that means, as like in VADL, we are giving the names to our entity, to our design. बरोबर आहे का नाही? आपण नाव देतो का नाही? फुल ऍड किंवा मग जी काय तुम्ही नाव देता. Similarly, in case of Verilog also, you can use the identifiers. That is nothing but the user-defined words for variable, function names, module names, block names, and different instances, right? So identifiers begin with a letter or underscore and can include any number of letters, digit, and underscore. That means in case of identifier, you can mention it in any way. For example, you can look at this example. In this way, you can mention the name. Simply, you can write the words such as adders, right? By underscore 8 underscore shift. So this is also name that you can give. Then underscore A, B underscore C. So this is the another way to mention the identifier, or simply read underscore. So this is the another way to use what we can say the identifier. But remember, VHDL was not case sensitive, but identifiers in Verilogs are case sensitive. That means whatever the identifier you are using at the beginning, the same identifier you have to mention at the end. Means without changing the uppercase and lowercase also. Without changing the uppercase and lowercase also. VADL मध्ये तो प्रॉब्लेम नव्हता. VADL वॉज नॉट केस सेन्सिटिव्ह. आयडेंटिफायर्स वर तुम्ही अप्पर केस मधले लिहिले, खाली लोअर केस मधले लिहिले, इथे चालत होतं. इथे चालणार नाही. बरोबर आहे. वॉट एव्हर द आयडेंटिफायर यू हॅव मेन्शन्ड ॲट द टॉप, द सेम आयडेंटिफायर यू हॅव टू मेन्शन ॲट द एंड. राईट? क्लिअर? समजलंय का? So this is about the identifier. Now we will discuss about the operators. Now operators are 1, 2 and sometimes 3 characters used to perform operations on variables. So all of you know about the operators. Greater than, less than, addition, subtraction, right? ANDing, ORing. So in case of VHDL, each operator has different symbol and syntax that we are going to discuss later. Okay. Now in case of Verilog, it has some restricted keywords. Means that Verilog module has some restricted keywords and that you cannot use in further cases. That means it has assign. So assign is a restricted keyword. That means assign is a Verilog keyword. You yourself cannot use assign for assign as a identifier or for some other purpose. No, right? So there are some a list of restricted keywords are there in Verilog that I will show you in next lecture. Okay, few I have mentioned here, such as assign, then case, then wire, register, or NAND, module. So these are the keywords, right? And they should not be used as an identifier, right? So these keywords म्हणजे तुम्ही आयडेंटिफायर म्हणून हे कीवर्ड्स वापरू शकत नाही. बरोबर आहे. हे सोडून तुम्हाला काहीतरी वापरावे लागतात. क्लिअर विथ दिस? असे बरेचसे कीवर्ड्स आहेत व्हेरिलॉग मध्ये दॅट आय विल टेल यू. ओके. नाउ about gate level modeling. So all of you have clear with this section, right? Gate level modeling means what the entire structure, how many gates are there in that entire Verilog code or VHDL code. So that is about gate level modeling. So some basic gates that you can use in Verilog, for example, AND, NAND, right, or NOR. So actually these are the keywords. The similar way we have used in VHDL also. For example, if you want to AND the A and B, right? तुम्हाला जर A आणि B चं AND ऑपरेशन करायचं, तुम्ही कसा कोड लिहिणार? AND A स्पेस B, बरोबर आहे. म्हणजे इथं AND म्हणजेच काय, हा कीवर्ड आहे. सिमिलरली AND, NAND, OR, NOR, XOR, NOR. Similarly, these are the basic gates that you can use in Verilog also, right? So these are the gates. Now you can use the buffers and NOT gates also in case of Verilog. So its keywords are buff, that means that is a buffer, and NOT, that means that is a NOT gate, right? So you can use the 3-state gates, right? Such as buffer 1, buffer 0, buffer not 1, not 2. So these are the buffers right? So that also you can use directly in your programming. Simply what you have to write this name as a buff FIFO, that means first in, first out buffer, and simply you can write its syntax, right? In this way, you can use the buffers also. Now, data types. Now come to the data types. We have studied the data types of VHDL also. बरोबर है? Now we have to study the data types of Verilog. Now, what are the different data types are there in Verilog? So, first type is a value set, right? 0 is nothing but logic 0, all false condition. 1 is nothing but logic 1. X is nothing but logic, unknown logic value, and Z is nothing but high impedance. That means here we have only 4 valued logic, 0, 1, X and Z. In case of VHDL, how many valued logic we have studied? Total 9 valued logic. So this is the second difference. VHDL is 9 valued logic, Verilog is 4 valued logic. Which 4 value? 0, 1, X and Z, right? Logic 0, logic 1, unknown and high impedance. This is the data type. Again, wire. Wire is a second type of data type. Now, what this wire means? A wire represents a physical wire in a circuit and is used to connect gates or modules. That means this wire is used to uh, wire represents the physical circuit, right, in the code, and that is used to connect the different gates and modules. The value of wire can be read but not assigned to in functional or block. That means whatever the value of that wire that you can read, but you cannot assign it to any uh, in a function or block. You cannot assign a new value to it. Wire does not store its value but must be driven by a continuous signal statement or by connecting it to a output of a gate or module. That means this wire does not store its value but must be driven by continuous assignment statement or by connecting it to the output. That means in this case, this wire represents the physical connection, but it will not hold up any permanent value, right? It will not hold any permanent value. Other specific types of wires are WAND, WOR, that is wired or, and tri, that means tri-state. This WAND is wired and, right? Wired and gate. WOR, that is WOR is wired or, and tri means tri-state buffer, right? So this is the some special types of wire. The next data type is register, right? What this register will do? Declare type register for all data objects on the left hand side of the expression in initial and always procedure or function. That means register has to declare at the left hand side of the equation. For example, you can go with this example. You have to start with this first letter register, then MSB, LSB, then register variable list. This is what, in this way you can use this register data type. For example, you can see here register A, that means it's a single bit register variable. Register 7 as to 0 and Tom, that means 7 as to 0 means how many bit? 8 bit. That means it has 8 bit vector, a bank of 8 bit register, right? A bank of 8 bit register. So this is, and this Tom is register variable list. Again, similarly, register 5 as to 0, that means it's a 6 bit variable, B and C. That means this B and C is of register data type, and each of one is of 6 bit. Each of one is of 6 bit. So in this way, you can use this register data type. Now next one is input, output and in-out. Similarly, in the same way that we have used in a VHDL. Input, then you have to mention MSB as to LSB and input port list. Similarly, output, MSB as to LSB output port list. And for bidirectional, that means in out, you have to mention in out, MSB as to LSB, input in out port list. So here are some examples, right? This input A, right? What is this? It simply states it's an default input to a wire, right? And it's a single bit. In output B comma C, that means two output which default to wire. Output 1 as to 0, that means it's a 2-bit output, right? And its type that you have to declare, right? Its type, data type that you have to declare. So again, see the last example. Register 1 as to 0 and C. That means this C, whatever you have declared, it's a data type of register and it's also a 2-bit, right? So in this way, you can use the input, in out and output. Now the integer type. Okay. Now the integer type. See, remember one thing. In exam, there will not be much question on this data types and all that. But why we are studying this? Without knowing this, you cannot able to write a Verilog code. बरोबर आहे. ह्याच्यावर तुम्हाला एवढं कोणी डिटेल प्रश्न विचारणार नाही, त्यामुळे घाबरू नका. परीक्षेत तुम्हाला काय प्रश्न येणार आहेत? राईट अ व्हेरिलॉग प्रोग्राम. डायरेक्ट तुम्हाला प्रोग्राम राहायचा आहे. बट यू आर नॉट एबल टू राईट अ प्रोग्राम unless you are not able to understand its syntax. बरोबर आहे. सिंटॅक्स समजल्याशिवाय तुम्हाला कोड लिहिता येणार नाही, आणि म्हणून we have to go for first syntax and then we will go for the Verilog codes. Okay, its logic is similar whatever we have used in Verilog, but just in a different manner we have to write the Verilog code, right? Just in a different manner we have to write the Verilog code. So that is all about the syntax. Okay, now integer also, there is a next data type, that is integer. The same we have studied in VHDL also. Integers are general purpose variable. That means integers are nothing but general purpose variable, right? And for example, how you can declare this integer? So integer A, that means A is an integer and assign B is equal to 66. That means this it's a single 32-bit integer. It's a why 32-bit? Because if you haven't mentioned its size, then what will happen? The Verilog will assume its default size as a 32-bit. बरोबर आहे. म्हणजे तुम्ही नुसता कुठला एक इंटिजर लिहिला, इंटिजर डी, त्याची डिफॉल्ट साईज 32-बिट हे कंपायलर अज्युम करतो. तुम्ही जर का त्याची साईज मेन्शन केली नाही किंवा रेंज मेन्शन केली नाही, तर त्याची डिफॉल्ट रेंज 32-बिट त्याची साईज it will automatically considered by the compiler, right? So this is about the integer. Then next one is supply 0 and supply 1. Now what is supply 0 and supply 1? This supply 0 and supply 1 defines wires that is tied to logic 0 and logic 1. That means logic 0 means ground and logic 1 means power, right? So how you can use that supply 0 and supply 1? So simply write this supply 0, right, or supply 1 and your variable. That means what it indicates? This this is the A and B are the logic 1. The A and B are at logic 1. Now simply here supply 0 means this is the ground pin and supply 1 means these are the power pins. So in that way you can use this supply 0 and supply 1. So its syntax is here: supply 0, then logic 0 wire, supply 1, then logic underscore 1 underscore wire. So you can mention the variables also. Okay, that means this A and B are connected to the logic 1. A and B are connected to the logic 1. So this is about the supply 0 and supply 1. Now next data type is time, right? The same thing we have studied in VHDL also. In VHDL also we have time variable or time data type also. So time is a 64-bit quantity that can be used in conjunction with the $time syntax task to hold simulation time. Time not supported for synthesis but can be used in simulation purposes. That means uh, in simulation purpose, if you want to hold the execution for particular time, then you can use this time data type. And how to use this? Its syntax is given here. Time, then time variable list. For example, time C, then C is equal to dollar, then time here you have to mention. That means this current simulation will hold for the time that you have mentioned. And how much time you can mention? It is a 64-bit quantity. That means you can mention time that can be represented as a 64-bit quantity. So this is about the time. Now next parameter, data type. Now what is this parameter? Parameters allows constant like word length to be defined symbolically in one place, right? Again, I will repeat. Parameters allows constant like word length to be defined symbolically in one place. That means this make it easy to change the word length later, right? With the help of this parameter, you can change the word length later. For example, this is the syntax for this parameter. Parameter, then the parameter identifier, that means parameter name, its value. The same thing you have to write here. And again parameter, then range, then the third parameter and is equal to its value. How to use that? Look at this example. Parameter add, that we have defined 2-bit, that is 00, comma, sub is equal to 3-bit, that is 111. So this is what we have defined. Then second parameter n is equal to 4. That means n is a parameter and its value is equal to 4. Similarly, you can define the parameter with the help of range also. Parameter 3 down to 0. This is the parameter name and it's a 4-bit and it is of 4-bit 1010. This is the range of parameter 3 down to 0, right? So in this way you can write a parameter also. So and what is the advantages of using this parameter? You can later in your later programming part you can change its parameter value, right? Its parameter value you can change at later part of your program. So this is about parameter data types. Now we will discuss about the operators, right? The same thing we have discussed in VHDL also. VHDL has 6 classes of operators, right? So same thing with some different context we are going to study in Verilog also. So now what are the different operators are there in case of Verilog? So first one, it has arithmetic operator. In arithmetic operator, what includes in arithmetic operator? So addition, subtraction, multiplication, division, right? Modulus. This percentage size is nothing but modulus, that is mod of something. This back hash line will be a division, then it's a multiplication, then it's a subtraction, and then it's a addition, right? So these are the arithmetic operators that you can use in VHDL. Okay. Now next, relational operators. Now what are the relational operators that you can use? Less than, right? Less than or equal to. Now in this case, this symbol means the less than or equal to, but in case of VHDL, that means the direction of passing of variable. VHDL मध्ये या सिम्बॉलचं meaning काय होतं? Direction of passing the value, that means will get, right? But in case of variable, it strictly means the less than or equal to. Now second one is greater than, then greater than or equal to, then equal to, and exclamatory sign followed by equal to sign, that is not equal to. बरोबर आहे? The same syntax we are using in C language or not? C language मध्ये तुम्हाला नॉट इक्वल टू दाखवायचं झालं तर तुम्ही कसं लिहिता? एक्सक्लेमेटरी आणि इक्वल टू साइनच देता का नाही, का वेगळा सिम्बॉल यूज करता? C language मध्ये हाऊ यू आर युजिंग नॉट इक्वल टू, हाऊ यू आर रायटिंग नॉट इक्वल टू, समथिंग इज नॉट इक्वल टू समथिंग, which symbol you are using in C language?
geometry only.
Yeah, the same thing only. The same symbol that you are using. The same symbol that you are using in Verilog also. So this is about the relational operators. Now next is a bitwise bitwise operators. That means this operator will perform the bitwise operation. So what we can say, this particular symbol is a bitwise not. Ampersand symbol is bitwise, and a single vertical line is bitwise or. Then the uh, triangle, or the what we can say, the sign which is similar to a mountain or triangle, a vertical triangle, that is bitwise XOR. Then this uh, horizontal S followed by this triangle, or this triangle followed by horizontal S, this is bitwise XNOR. So these are the different bitwise logical operators that you can use in Verilog. Now logical operators, right? So this ampersand single ampersand sign means logical not, double and means logical and, double vertical line means logical or. Double vertical lines means logical or. Clear with this? So these are the logical operators. Then reduction operators are there. Now what this reduction operator? This reduction operators operate on all the bits of an operand vector and return a single bit value, right? Means this reduction bit vector means, suppose for example, if you want to perform the AND operation of 8 bit and you require a 1 bit output, in that case you have to use this reduction operators, right? Means and there will be a n number of bits, it will perform that required operation on that n number of bits, and it will get a single bit result for you. It will get the single bit result for you. So that is the reduction operator. Again the same with some little bit modification that we have used. Single ampersand means reduction, and a vertical line means reduction or. Then horizontal S followed by ampersand, that is reduction NAND. Then reduction NOR, reduction OR, reduction XNOR. So see, you have to mug up these things. Why? Because while developing this language, this syntax has been fixed by the language developers. We cannot do in that. हे तुम्हाला पाठ करावे लागणार आहेत, सगळे सिम्बॉल लक्षात ठेवावे लागणार आहेत. त्याच्यात आपण काय करू शकत नाही, बिकॉज द व्हेरिलॉग डेव्हलपर हॅव फिक्स्ड दिस सिम्बॉल, आणि त्याचं ऑपरेशन त्याने ठरवून ठेवलेलं आहे. त्याच्यात आपण काहीच करू शकत नाही, राईट? सो दिस इज अबाउट द रिडक्शन ऑपरेटर्स. देन देर आर शिफ्ट ऑपरेटर्स. सो there are some shift operators that you can use. Now what is role of these shift operators? Shift operators shift the first operand by the number of bits specified by the second operand. बरोबर आहे? जसं तुम्ही शिफ्ट ऑपरेशन करता का नाही, शिफ्ट बाय 8 bits or shift by 2 bits, shift by 5 places. Same way this shift operator will perform the shifting of the first operand, and how many places it will shift, that has to be specified by the second operand. बरोबर आहे? म्हणजे फर्स्ट ऑपरंडचा नंबर शिफ्ट करणार, किती बिटनी शिफ्ट करणार, सेकंड बिटच्या ऑपरंडचा नंबर एवढ्या बिटनी तो शिफ्ट करणार. Vacated positions are filled with zeros for both left and right shift. That means whatever the vacated position that you have shift, that can be filled with the zero, and its symbol is double, right? Double less than sign is a left shift, and double double greater than signs are right shift, and double less than signs are left shift. For example, a sign C is equal to A, right? Double less than sign, that means shift left 2 places, राईट? म्हणजे ह्या लाईनचं मिनिंग काय होतं, ए हे जे नंबर आहे तो 2 बिटनी लेफ्ट शिफ्ट होणार. ए हा जो नंबर आहे तो 2 बिटनी लेफ्ट शिफ्ट होणार. सो दिस इज हाऊ दिस शिफ्ट ऑपरेटर वर्क्स. Then next type is concatenation operator, right? The next type is concatenation operator. What this concatenation operator will do, right? And its symbol is curly bracket. Its symbol is curly bracket. Concatenation operator combines two or more operands to form a large vector, right? Means whatever you will whatever the two different operands you will write in that curly bracket, it will combine that and it will form a vector. For example, you can see here, assign x is equal to 1 bit of 0 and a. That means, and that we have written in curly bracket. That means this is a concatenation operator. And what will be the result of it? X2 is equal to 0, x1 is equal to a1, and x0 is equal to 0. That means whatever you have written here, whatever value of a, right, that you have written in this case, it will combine that operand and it will form a one large vector out of that. So this is about the concatenation operator. Okay. Now next is a replication operator. Okay, next one is a replication operator. What is the role of this replication operator? The replication operator makes multiple copies of an item, as the name indicates. A replica. What is meaning of replica? A duplicate copy, right? Or the same to same copy that you can say. That means the replication operator will exactly produce the same operator with same type, राइट. रिप्लिकेशन ऑपरेटरचं काम काय? एक्झॅक्टली त्याची फोटोकॉपी तयार करणे. एक्झॅक्टली त्याची फोटोकॉपी तयार करणे. अँड इट्स हाऊ टू यूज दॅट इन कर्ली ब्रॅकेट अँड देन आयटम्स curly bracket end and the major curly bracket. So this is the syntax to use this replication operator. How you can use this replication operator? In this way, right? It indicates this item that you have mentioned, right? It has to copied 2 times. This item that you have mentioned, this n is a replication number. That means how much time that operator has to copy? 2 times. 2 times that operator has to copy, right? So this is how you can use the replication operator. Now next is a conditional operator, right? So depending upon some condition, this operator will work. Now conditional operators in Verilog are much similar or much like the that you have used in C and C++ language. Right, so they can evaluate of the two expressions based on condition. It will synthesize to a multiplexer. That means this operator, how this operator works? Condition, question mark, result if condition true, result if condition false. Likewise, assign a is equal to g. That means g is a condition. If, then x will get y. That means after this, result if condition true. That means if a is equal to g, then x will happen, and if condition false, then y will be the answer, or y it will get, like a multiplexer, right? Multiplexer. If g or if condition is g, that means now in this case, if g is equal to 0, then x, and if g is equal to 1, then y. So in this way, you can use this conditional operator. Okay. Now, these are the operator precedence. As we have the same thing we have seen with the VHDL language also, that have some 6 class of operators, and each operators have precedence, right? And each class also have the same precedence as of the entire precedence. So in case of VHDL also, this operator have some precedence. Now what is that? These are the operator, its name, right? And its precedence is always from highest to the lowest, right? That means operators on the same level evaluate from the left to right, and it's strongly recommended to use parentheses to define order of precedence and improve the readability of our code. That means it's also precedence is from highest to lowest. That means from top to bottom, top to bottom. The same precedence that we have seen in VHDL also. VHDL also has precedence of highest to lowest. That means from top to bottom. Means top article has highest precedence, bottom article has lowest precedence. So in this case also, in case of VHDL also, operator has top to bottom. That means highest to lowest precedence. So this is about the operator precedence. Now we will talk about the operand, right? We will talk about the operand. So the same part we have discussed in VHDL also. VHDL also there are different operands are there in Verilog, but obvious there should be some operands that we can use. Okay. Now whatever we have covered up till now, if you have any doubt, you can ask me right now. आपण काय बघितलं आजच्या लेक्चरमध्ये व्हेरिलॉग, बरोबर आहे, त्याचं स्ट्रक्चर, मग व्हेरिलॉगचे सिंटॅक्स म्हणजे व्हेरिलॉग मध्ये डेटा टाइप्स कुठले आहेत, व्हेरिलॉग मध्ये ऑपरेटर्स कुठले आहेत, बरोबर आहे, प्रत्येक डेटा टाइपचं फंक्शन काय, प्रत्येक ऑपरेटर फंक्शन काय, बरोबर, डेटाला सॉरी व्हेरिलॉग इज अ फोर व्हॅल्यूड लॉजिक, ते आपण बघितलं. व्हेरिलॉग हॅज 4 लेवल्स ऑफ ॲब्स्ट्रॅक्शन. कुठकुठले आहेत? फर्स्ट वन इज अ अल्गोरिथमिक लेवल, नेक्स्ट वन इज RTL, नेक्स्ट वन इज गेट लेवल अँड लास्ट वन इज स्विच लेवल. बरोबर आहे. VHDL मध्ये फक्त 3 लेवल, अल्गोरिथमिक, RTL, गेट लेवल. बरोबर आहे. VHDL मध्ये स्विच लेवलची दिसत नाही, व्हेरिलॉग मध्ये ते तुम्ही पाहू शकता. बरोबर आहे. तर एवढा पार्ट आपण आतापर्यंत व्हेरिलॉग मध्ये शिकलो. कुणाला काही आतापर्यंत जे शिकलोय त्याच्यात काही कळलं नाही, कळलंय? ऑल ऑफ यू आर क्लिअर विथ धिस? समजलंय का सगळ्यांना सगळं?
Yes, sir.
Okay, fine. Then we will stop here. From next lecture, we will start our discussion with this operand, right? We will discuss what are the different operands that we can use in Verilog programming, right? We will stop here.
So can you please send this PDF on group?
Yeah, sure. Every material that I am having with me, I will share with you, no problem.
Okay, sir.
DDH मध्ये तुम्हाला काय अडचणी देत नाही. I will provide you handwritten notes, I will provide you PDF, PPT, assignments already I have given to you, I will provide you MCQ questions, right? Everything I will provide you. So don't afraid of this subject. घाबरू नका. आणि हे जे आपण बघतोय, आज जे आपण शिकतोय, ते काय तुम्हाला एक्झाम मधल्या पॉइंट ऑफ व्ह्यूनी तेवढं इम्पॉर्टंट नाहीये, पण हे आपण का शिकतोय? कारण त्याशिवाय तुम्ही व्हेरिलॉगचा कोड लिहू शकणार नाही. एक्झाम मध्ये तुम्हाला डायरेक्ट क्वेश्चन काय येणार? राईट अ शॉर्ट नोट ऑन टाइप्स ऑफ ऑपरंट्स इन व्हेरिलॉग, बरोबर आहे. सिम्पल क्वेश्चन येणार. सो यू हॅव टू इलॅबोरेट ईच अँड एव्हरी टाइप इन 1 or 2 लाईन, सिम्पल. किंवा डायरेक्ट क्वेश्चन येणार, राईट अ व्हेरिलॉग कोड फॉर फुल ॲडर, दॅट्स इट. आपण काय शिकलो? व्हेरिलॉग कोड फॉर VHDL. आता काय येणार? VHDL कोड फॉर फुल ॲडर शिकलो आपण. आता लँग्वेज बदलायची, फक्त लॉजिक तेच राहणार. व्हेरिलॉग कोड लिहायचा त्याचा बाय युझिंग Verilog language syntax. This is what now in this unit we are going to study. Okay, very simple. Probably tomorrow or day after tomorrow I will share this PDF with you. Okay, tomorrow only I will share this with you in that sheet also and with on group also. Okay.
Okay, sir.
Okay, fine. We will stop here.